Dry ice is solid carbon dioxide. A 0.050 gram sample of dry ice is placed in an evacuated 4.6 liter vessel at 30 degrees Celsius. Calculate the pressure in atmospheres inside the vessel after all of the dry ice has been converted to carbon dioxide gas. So what do we have? We have an amount in grams. Of course, in order to work with most of our problems in chemistry, we don't use grams, we use moles. So we have an amount, 0.050 grams, which we are probably going to want to convert to moles. Okay, what else do we have? We have 4.6 liters. 4.6 liters. What kind of a measurement is that? Well, liters is a measure of volume, so we have 4.6 liters is a volume. We also have 30 degrees Celsius. That is a measure of temperature, so we have 30 degrees Celsius. This is a measure of temperature. Okay, and we're looking for a pressure. We're going to calculate the pressure in atmospheres. So pressure is what we're looking for in atmospheres. Okay, so again, we have an amount, we have a volume, we have a temperature, we're looking for a pressure. Since we don't have a change in anything, we don't have a change in pressure, an initial pressure and a final pressure, we don't have a change in volume or change in temperature, we must be looking at the ideal gas equation. PV equals nRT. Because all of our other gas equations involve variables that are changing, right? Such as P1, V1, right? A T1, a P2, a V2, a T2. Here, we don't have any of that. We have one volume, one temperature, one pressure, one amount. What are we solving for? We're solving for pressure. So, pressure is going to equal nRT divided by V. So let's go ahead and start putting some numbers in here. Again, N we have in grams. Of course, in chemistry, we don't measure amounts in grams. We measure them in moles. So let's go ahead and do that. 0.050 grams of carbon dioxide. Okay. We want to convert this into moles. So 1 mole carbon dioxide. Hopefully you have a periodic table handy. Carbon weighs approximately 12.01 grams per mole. Each oxygen, 16.00. So let's see here. We will have 44.01 grams. 44.01 grams per mole of carbon dioxide. So let's see how many moles we have. We have 0.050 divided by 44.01 tells us that we have 0.00114 moles of carbon dioxide. All right. What else do we need to convert before we go any further? Our temperature is in degrees Celsius. If you will remember our R value, when you look that up, the units of temperature and volume and amount in R are always the same. Volume is always measured in liters, temperature is always measured in Kelvin, and amount is always measured in moles. It's the pressure unit that changes in R. So we need to convert our temperature into degrees Kelvin. It's a super simple conversion. To get from degrees Celsius to degrees Kelvin, you simply add 273. So 30 plus 273 gives us a new temperature of 303 Kelvin. Okay. All right, and our R value is something that we look up on a table. In this case, since we're looking for atmospheres, we want an R value that corresponds to atmospheres. So we have 0.08206, and this particular R is in liters per atmosphere over mole Kelvin, which is just what we're looking for. So pressure is going to equal, N is 0.00114 mole. R is 0.08206 liter, atmosphere, mole, Kelvin. T is 303 Kelvin. Divided by V is 4.6 liters. So you'll see that the moles cancel, the kelvins cancel, the liters cancel, leaving us with atmospheres, which is what we want. So our pressure is equal to 0.00114 times 0.08206 times 303 divided by 4.6 gives us 0.00616 atmospheres, or 6.2 times 10 to the negative third atmospheres.